Okay, let's consider this problem. 80 marbles are to be distributed among 15 children. And how many ways can this be done so that each child receives at least 3 marbles? So here obviously this is another combination problem with repeats, but it's more complicated than the past ones that we considered, and the way it's set up, we cannot solve it just simply by using the formula for repeats that we had derived in previous videos and that we used in previous videos, because nothing in this formula accommodates for the fact that when we're distributing the 80 marbles, that each child has to have at least 3 of them. So here is where we use generating functions. Now, we've had several videos concerning introduction to generating functions and some of their basic properties, and then we used generating functions for solving simple kinds of problems. If you just found us on YouTube, if you will go to the website at digital-university.org, all of the videos that we have concerning combination and permutation problems and probability, they're all listed in their proper order there for you. So that's at digital-university.org. Okay, now let's go back and consider this problem and how we're going to solve it using generating functions. So there's 15 children that are going to be receiving some marbles, and they receive multiple marbles. That's what makes it a combination with repeats problems. The order in which they receive the marbles is irrelevant, so it's not a permutation problem, it's a combination problem. Now, let's just for a moment imagine that we didn't have this restriction. We simply had 80 marbles to be distributed among 15 children, and there was no rule set up as to how many marbles each child could receive. In one kind of a distribution, one child might receive all 80 marbles, and the other 14 children might not receive any. Or one child might receive 1 marble, and then the 80 marbles will be evenly distributed amongst the other 14 children. There's all kinds of ways to do it, and we want to know what is the total number of ways. So if we had the problem set up where it was just simply 80 marbles to be distributed among 15 children, then for each child the generating function would be 1, which is x to the 0, meaning they might not receive any marbles, or they might receive 1 marble, x to the 1, or the child might receive 2 marbles, or 3 marbles. There's no restriction put on it, or 4 marbles, and we can continue, and this continues on out to infinity. Now here you might think, wait a minute, why should this go out to infinity when the most marbles that any child could receive would be 80? It seems like this should stop. At x to the 80, that should be the proper expression. And this is a point of confusion here sometimes. No, that's not true. It continues on out to infinity. And this is the and that's true. Now this is true for each child if we just consider the problem like this, in these terms. This is this, as we have pointed out in the previous videos. Then, to consider all 15 children, we multiply all 15 generating functions together, so that would be 1 to the 15, which is 1, divided by 1 minus x to the 15, which equals 1 minus x to the minus 15. Then what we do is when we expand this out, now we're concerned about the coefficient of x to the 80. That coefficient there of x to the 80 would tell us the total number of ways that 80 marbles could be distributed among 15 children. Now, if we had, say, one child could receive no more than say 4 marbles, then for that particular child, the generating function would be 1 plus x squared plus x cubed plus x to the 4th. And for that child, it would stop right there, because you put that restriction on saying that child cannot receive any more than 4 marbles, or that child can have a maximum of 4 marbles. What we'll do is, in the next video, we'll consider a problem that has these kind of built-in restrictions. You can see that, hopefully by now, you've appreciated that generating functions can be very powerful for solving problems that we simply could not get a handle on otherwise. But it's impossible in one video to show the kind of basic properties of generating functions and how to use them in each instance. So all we can do is try and address them by presenting a series of videos. But okay, let's go back to our current problem. Here, the problem is stating not just that 80 marbles are going to be distributed amongst 15 children, but each child has to receive at least 3 marbles. So that means that for each individual child, the generating function is not this, it has to start at x cubed. So, for each child, the generating function is x cubed plus x to the 4th plus x to the 5th plus x to the 5th, and so forth, like this. And that would be for each child. They might receive, well, they're going to receive 3 marbles, or they might receive more than 3 marbles. Okay, now we're going to have then, when we're going to consider all 15 children, then we multiply all 15 generating functions together, so that would give us this to the 15th power. Now, when we have this, we multiply this out 15 times, now we're concerned, what is the coefficient of x to the 80th power? And that number there will then tell us how many ways the 80 marbles can be distributed amongst 15 children, so that each child receives at least 3 marbles. So let's look at the problem here. Now, notice that from this expression right here, we can factor out x cubed. So we're going to have x cubed times 1 plus x squared plus x cubed, and it'll keep on going like that. So this expression is this expression, and this is going to be x to the 45th, so we have x to the 45th times 1 plus x squared plus x cubed plus x to the 4th, and it continues on out like this. And what we're interested in now is, from this expression, what is the coefficient of x to the 80. Well, you can see now here we factored out x to the 45, so that's the same thing as asking from this expression, what is the coefficient of x to the 35? And this expression right here we know from our past videos we can set that equal to this. So here then we have, this is to the 15th power here. We left that off, sorry. Okay, so we have this to the 15th power, which will equal 1 to the 15, this divided by the 15th, or that's 1 minus x to the minus 15. And now our strategy is we want to find the coefficient of x to the 35. And we say now not x to the 80 because this was factored out. So from this expression we need to find the, we're interested now in x to the 35th power, so we want to find that coefficient. And we're not going to grind out all of the numbers, but using our knowledge from the past videos on binomial expansions, when you have a negative exponent, we have this 1 minus x to the minus n. From our past videos now, we know what this equals. This binomial coefficient, which is just 1, but we write it like this so we can remember the pattern, plus then the next one is n plus 1 over n minus 1 x squared plus n plus 2 n minus 1 x cubed, and this goes all the way on out to infinity. But what we're interested in is the coefficient of x to the 35th. And that is n plus, this number is 1 less than this number, so that would be 34 divided by n minus 1. And in this problem, n is equal to 15. We had 1 minus x to the minus 15. The minus sign is out here, so n equals 15. So here 15 plus 34 is 49. 15 minus 1 is 14. So this binomial coefficient, that is the coefficient of x to the 35th. So when we figure this out, that then will give us the number of ways that 80 marbles can be distributed amongst 15 children, and each child receives at least 3 marbles. And of course, we know how to handle this. We're not going to go ahead and grind out all the numbers, but we know that would be 49 factorial over 14 factorial times 35 factorial. Go ahead and grind the numbers out, and that will give us our solution. We're not going to do that. Obviously, you know how to do that yourself. What we want to show is, in this video, is kind of the logic and the thinking that goes in to how we can solve this problem with these restraints here, using generating functions, because there's no way that we could solve this problem simply by plugging it in to our standard formula. We have to use generating functions, and hopefully we've demonstrated to you then kind of the thinking that's involved when you want to use that approach. Okay, that's all we really want to say about this video. Now come back and join us in the next video, and we're going to consider another problem like this, and there's going to be a lot more restrictions thrown in, and you can see that it would be hopeless to try to approach that problem unless we use that powerful tool of generating functions. So come back and join us for that video, and let's see what happens.